let us discuss about naturally occurring polymers. Today we'll discuss about polysaccharides. Carbohydrates are the most abundant organic compounds containing 3 fractions of the dry weight of plant world. They represent great storehouse of energy as food for humans and animals. About 400 billion tons of sugar is produced annually through natural photosynthesis, dwarfing the production of other natural products with the exception of lignin. Much of this is produced in the oceans, pointing out the importance of harnessing this untapped source of food, energy, and renewable feedstock. The potential complexity of even the simple aldohexose monosaccharide is indicated by the presence of 5 different chiral centers, giving rise to 2 to the power 5 or 32 possible stereoisomeric forms of the basic structure, two of which are glucose and mannose. While these sugars differ in specific biological activity, their gross chemical reactivities are almost identical. Carbohydrates are diverse with respect to both occurrence and size. Familiar mono and disaccharides include glucose, fructose, sucrose, cellulose, and mannose. For instance, cotton is a good source of cellulose, yet the amount of cellulose varies from 85% to 97% depending upon the variety of cotton plant, age of plant, and location of growth. Again, the gross chemical reactivity and resulting physical properties are highly independent of the source of the cellulose. The most important polysaccharides are cellulose and starch. These may be hydrolyzed by acids or enzymes to lower molecular weight carbohydrates and finally to D-glucose. The latter is the building block or mark for carbohydrate polymers, and since it cannot be hydrolyzed further, so it is called monosaccharide. Cellulose and maltose, which are repeat unit of cellulose and starch, are disaccharides consisting of molecules of D-glucose joined together through carbon atoms 1 and 4. The D-glucose units in cellulose are joined by beta-acetyl linkage, while those in maltose are joined by alpha-acetyl linkage. The hydroxyl group in the beta form of D-glucose are present in equatorial positions, and the hydroxyl on carbon 1 in the form of alpha form in the axial position. While the chair form shows D-glucose, cellulose and maltose exist in all disaccharides and polysaccharides.